Hello and welcome to today's class. Today we have this challenge on the board here. The question says k to the power of k equal to k to the power of 2. We are asked to look for the value of k here. And in this challenge, you see or you observe that we have to find at least two values of k that will satisfy this challenge. So if you're new here, this is Online Maths TV. If you will not subscribe, subscribe. Okay? So yeah, we take our solution. All right. Now, in this equation, this exponential equation, the first thing we're going to do here is easy. Let's put down the question. We have k to the power of k equals to k to the power of 2, right? So the first thing to do, or the best approach to apply there is to apply log to both sides of the equation. Okay, we could as well use the log base 10, but here I'm going to use the ln base e. So taking the log of both sides, we're going to have here the ln of our k to the power of k, equals to the ln of our k or to the power of 2. Okay, so in this, we apply the property of logarithm, which says that if you have the ln of your a all raised to the power of b, you say move this power back here, and so this is going to give us b times the ln of our a here. And so if we suck up to this, we're going to move the whole of this back here and the whole of this too back in here. Right? So this is going to give us our k times the ln of our k, or let's put this in bracket, equal to our 2 times the ln of our k also. Okay. Yeah, if you decide to divide through by the ln of k, because here we have ln of k, here we have ln of k here, right? So if we decide to divide by ln of k here, then we're going to run into trouble. In other words, we're going to solve for just one value of our k, which is k will be equal to what? 2. But here we are asked to look for two values. So what we do here, we just have to make another substitution. We make a substitution here, right? Okay, so the substitution we're going to make here is this. Look at our ln of k. Let's bring this something to represent it here. Okay, so there we say let's take the ln of our k, right, be equal to u. Okay, so if we say let the ln of k be equal to u, if we decide to bring this u into the system, we're going to have our k dot u and here 2 times u. So we're going to have this as a variable and we're still going to have this as a variable. So we're going to have two variables and that will not all go away. And so from this expression we have in here, let's make k the subject of the formula. And for us to make k the subject of the formula, we're going to write e to the power of ln of k, then this I will also write e to the power of u. Okay, because we know that if you have your e to the power of the ln of a, this is equal to ra, because this leaves the system, right? So with that, this also means, therefore, we can get our k from here. K will now be equal to e to the power of u. So we now have k is having its value here, and here we have u equal to this. So we're going to substitute these two quantities into this equation. So we take from here now, here. So let's take from here. What is our k? Our k is e to the power of u. So we have e to the power of u times, then what is our ln of k? ln of k is equal to u. So times ru is equal to, we have 2 times ln of k here again, which is also u. Easy. All right. Now from here, we look up again. Let's rewrite this. This will give us here ru times e to the power of u, then equal to our 2u. All right. So from here, what we do here is easy. We just have to move this quantity to this side of this equation. So this is going to give us our u times our e to the power of u minus our 2u equal to 0. Let's continue here. Now, let's look at this here. We are having here u here. So let's factor out u from here. Again, the reason why we decided not to divide through by u are because we are having here to the power of this. Okay, so from here, if we factor this out, this is going to give us our u bracket e to the power of u, then minus r2 equal to r0. So we apply the 0 property, whereby we equate this to 0, we equate this to 0. So we're going to have here case 1. Our case 1 says that our u will now be equal to 0. But again, what is our u? Look at what we made here. We said let ln of k be equal to u. So we have our u to be ln of k. And so this is going to give us the ln of k is equal to 0. So for us to get our k here, we just have to introduce e here. So we're going to have here e to the power of the ln of rk. This other side, e to the power of 0. This is ln base e. And so this will leave the system according to this expression here. So we are left with k is equals to e to the power of 0 will give us what? 1. So we have the first value for our k to be 1. All right, let's check if we put 1 into the system, if it will give us a solution to satisfy the equation. So we have here 1 to the power of 1 will give us 1. Then 1 to the power of 2 will give us 1. So 1 as a solution satisfy the original equation, right? So let's take case 2. Our case 2, we're going to take here e all raised to the power of u minus r2 equals to 0. Move this to this side, so we have e to the power of u is equals to 2. So let's continue here again. Now we are having our e to the power of u. And what is our u? Remember, our u is ln of k, right? ln of k. So this is going to give us our e to the power of the ln of our k is equal to 2. Wow. Now, here we are having e, here we are having ln base e. And so this leaves the system, right? Good. Or better still, if we don't want to do it, okay, that is the best way, okay? Because if we decide to move the whole of this backward, then it will still give us k. Okay, so this leave the system. This is going to give us k is equals to 2. So we've got another value for our k, which is the k2. Now let's check again if we put the 2 into this expression, if it will satisfy the expression here. So we have 2 to the power of 2 will give us 4, and here we have 2 here to the power of 2 here will give us 4. So the two answers we solve for, we have here k1 equal to 1 satisfy the original equation, and k2, which is equal to 2, also satisfy the original equation. So this brings us to the end of this math class. If you learned something from this video tutorial, do not forget to give the video a thumbs up. Okay, we bring more video your way these days. If you've not subscribed, subscribe to our channel. This is Online Maths TV. We love you. Thanks for being there, and we keep loving you till the end of time. Bye. Until we come your way, keep winning.